You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session.
All right, so we're going to have a great one today, folks. Jerry is truly the wizard of coding. He's also happens to be a very good friend of my brother Len and one of the nicest guys you'll ever meet. So this is going to be a good one. All right, Jerry, so here's what I got. I got castings in my machine shop. They're coming out of my machine shop. I put them in a box. I ship them to the coder. Walk us through what you will look for and some of the methods you might do to prepare that for coding.
The first thing I'm going to do when I open the box is I'm going to have the print with me. And I'm going to look at the casting to see if it was any prep work was done before it was put in the box. Then I'm going to look for flash. If the spec says remove all flashing, of removing that flash and getting that casting ready for coating.
Are the customers required to provide this process sheet, or is that often developed internally with back and forth with the customer?
That's a great question.
I always like for it to be a collaboration so that the caster knows what he needs to do before he puts that casting in a shipping container to go to the finisher, and the finisher needs to know exactly what that caster is looking for. There are some castings that I have powder coated and liquid coated before, and they didn't really care about bubbles and things because it was an internal part. But when we're talking about the kind of business that Batesville Products does, they deal in some very, very high end. They demand perfection. Tim and I and Lynn, we worked on a project several years ago where there couldn't be a speck of dirt anywhere on that part. That's how critical it was. So yes, writing up that procedure needs to be, you need to have all the team sitting in a room and agreeing on that so that there's no question.
Hey, Jerry,
yes.
Another quick question I've got is, so you've got the process sheet that you've written up for the casting. Let's say this part goes on like a medical cart. So you've got the casting as the base, and then maybe steel or some sort of fabrications, maybe some tubing. Is the process sheet good for is that one process sheet good for the entire assembly, or is there a process sheet per the casting, a process sheet per the extrusion? In other words, do you just throw them on the line and run them all through together at the same time?
Tim, that's a great question. The good thing is the steel parts, absolutely. You can batch those with the casting when the castings are prepared for finishing. Normally, aluminum extrusions, they can stand the heat as is. So if it is an assembled part that you're going to be liquid coating or powder coating, and it is a baking system, your secret is your cleaning. You would want to use a multi-metal coater cleaner, because for paint to adhere to aluminum, you have to have fluoride in your cleaner. Now, it's a very small percentage of fluoride, but without the fluoride, the especially extrusions, the paint will not adhere. You will have loss of adhesion. And what that does in one step, it cleans the part, and it also puts the coating on there that is reacting with the metals and prepare the steel. It's going to leave the conversion coating on there. And on the aluminum, because there's fluoride, it's going to etch it. So yes, you can paint those together, but it is critical, very critical, that whether you're dipping or whether you're spraying through a full line system, or whether you're cleaning with a hand wand, you always want to use a multi-metal coater cleaner. Now, if I'm putting a air dry primer on it and an air dry paint, I'm going to just clean it up really well. I may put some anodize on it. I may just do a chemical wash where I put iron phosphate, or there's so many nano chemicals today that are so friendly that I would prepare it so that the paint has something to bite to. And I'm going to process it. And when it's done, it's going to look very good. I'm going to wrap it back up, put it back in the box, send it to the customer.
When would you primer a part? And what does that do for you?
Well, a lot of times, and that is a really good question, because again, it gets back to process and what the end user is expecting. But a lot of times, castings will have scratches on them, and so putting a primer on, we say it this way: it hides all the sins. It makes the part smooth and just lays the coating down so much better. Because any imperfection, a rejected part equals 3 parts. You've lost 3 parts when you reject a part. You lost that part that you could have painted with it, and then you lose that line time when you have to repaint that one. So it really becomes cost effective to know what the expectations are and address that in the process. Now, if I have a baking system, because castings have air entrapped in them, if I do not degas those, I have a really high chance of blowing the casket up. The paint goes on, it looks really good. We put it in the oven, but because it gets up to 300 to 400 degrees, that casting expands, it releases the air, and it blows the paint off the part. So what I would do with that particular casting, and this happens more with high-end heavy castings, I would pull that casting, and I call it the 15-15 rule. If my paint or powder, and we'll just use 325 degrees as our set point, this particular coating for this casting needs 10 minutes at 325 degrees to cure. Then before I do anything, after I've prepped the casting, I'm going to put it in an oven at 340 degrees for 15 minutes. I'm going to expand that casting, let all the gas, the air get out of it, cool it back to ambient. Everything's going to be the same as it was when it came out of the box. Now, when I apply the paint, it's only going to be in the oven for 10 minutes at 325. That casting will not open back up, because when I did my 15-15 rule, I degassed the casting. That 15-15 rule is always my starting point. At 15 degrees higher, 15 minutes longer than the cure, so that I know that first casting is going to be perfect.
So if you have an aluminum casting that you heat treat, does the process still need a bake-off or a degassing step?
You would look at the heat treat and see what temperature was that product processed through. If that heat treat is at a higher temperature than the coating that's going to be used, you should be able to go straight from the heat treat, cool to ambient, and then either spray your wet paint or your powder coating on there. The industry, and this has been a trend for, I would say, for the last 25 years, it is rapidly moving more to powder coating, because powder coating is a true green technology. It does not have any volatile organic compounds in it. And when we talk about that in the paint and powder industry, we just refer to it as VOC. Well, that's volatile organic compounds. That's the carbons that are going, everything that's going into the atmosphere. A lot of folks now are requesting lower cured powders, and powder continues to come down in temperature. 15 years ago, I would have told you I can't get you a powder less than 375 degrees. Today, there's some on the market that are 275. Again, that's leading more to powder. A lot of companies now, and I'm working with one in particular, they're going to add an oven in their line so that they can go ahead and load their casting. They will degas them, then they will go through the cleaner, then they will go through the powder booth, and then they will be cured. And so they're not having to handle them 3 or 4 times. They're doing it all in line and doing it in one step.
So, hey, Jerry, so let's talk a little bit about the types of powder coating finishes and maybe some of the properties of some of the various powders.
Okay, that'd be great. Great. The most popular powder in the world is a TGIC polyester. And the reason it's so popular is that you can use it in an interior, but it's made for exterior. So if you're looking at a rail fence or a really nice painted gate, you would want to use a TGIC because it's going to give you much, much life. There are powder coatings now that are, they're very expensive and they will last 30 years with no problem. So TGIC polyesters are the most popular powder that is made. Europe wants to back down on the isocyanate that is in the TGIC. That's what the I stands for. And we call it a TGIC-free polyester. Again, it is an exterior powder. There is an acrylic. The good news is acrylics last forever. The bad news about an acrylic powder is it will contaminate any other powder. So people that use acrylics, that's what they use, just acrylics. And that is like if you go out and buy a charcoal grill, 2 feet square, 8 inches deep, more than likely if it's powder coated, it's powder coated with acrylic because it can stand the heat. Then there are hybrids. And this is a blend of an epoxy and a polyester. If you have a powder coated desk in your office, that's hybrid powder. That's what the metal office furniture industry uses. And then there are epoxies. Now, there are many epoxies. Epoxies are only for interior. If you put it outside within 30 days, it will chalk, lose its shine and its color. If you look at, as you're driving down the road and you look at a fire hydrant, that fire hydrant is coated inside with fusion epoxy. And the reason that is that you can build that up to 20 or 30 mils thick. But again, it never sees sunshine because it's inside. Also, epoxies are very resistant to chemicals. And so batteries, a battery tray that batteries are going to set in would call for an epoxy.
Hey, Jerry, our good friend, our mutual friend, Terry, has some paints or powders or coatings that some of them insulate and some of them actually do the opposite and help the part get rid of the heat. Is that a powder or is that a paint? How does that work?
Well, you can do either one. The secret is the pigmentation. A good example is a window. You paint a window frame and the sun, instead of it heating it, it loses heat because the paint will not allow the heat to come in. It reflects the heat away. On the other extreme, with the proper pigmentation, it will reflect the heat away from it.
So I can buy a ton of metal today and I can use it and pour it 3 years from now. Is there a life to the powder?
Powder coating needs to be stored in a controlled environment. I always tell folks, let's try not to get the room over 75 degrees, and let's try to keep the humidity right around 40. That powder will last unopened for a year. If you store it in a building that gets up to 120, 130 degrees, the powder particles will start to melt to each other. And when you spray it, you'll have dirt. We call it low film grit all over your parts. So rule of thumb, 75 degrees, 40% humidity, a year, you're going to be great.
Okay, so now the paint's on there or the powder is on there. How do I know if it's going to hold? How do I know if it's going to peel off? Or what do we do? What do you do? What kind of tests do you do or recommend as a just to ensure that you've done the right process and the proper procedures were followed?
The best thing to do is to buy a crosshatch adhesion test kit that will cut straight lines. You cut north to south, and then you cut east to west, and you form these tiny 1/16 of an inch squares. Then you put tape on there. You press the tape down very, very hard. You wait 1 minute, and then you rapidly jerk that away. If none of the squares come off, that is scored as a 5B, which means 100% adhesion. Another thing that you can test is you can take a pencil and you can push a number 2 pencil. You flatten the tip of the pencil, you gouge it into the paint, and if it breaks the lead, you have a good coating and a cured coating. If it goes and it chips the paint off or the powder, you're more than likely undercured, because when powder is undercured, it is almost like glass. You could take a part and bang them together and you will actually see the coating shatter. Those are the two best ways. The quick way is to take either MEK, which you can buy at Lowe's, it's methyl ethyl ketone, or acetone, which is basically fingernail polish remover, and you saturate a rag, you put it on the part, and you take about a 3-inch swipe back and forth, and that's called one rub. It's called one double rub. Do that 25 times in the same spot, and if you do not go through the substrate, you have a good part.
So how do I know? So in our industry, in the casting industry, I can take a slice of a casting and send it off and have it analyzed, and they'll tell me what's in that. How do I know the powder's any good? How do I know what's in the powder?
Well, you will get from your powder source a safety data sheet, and that safety data sheet will give you all the information that's required by the federal government. The best thing, and then you'll get a technical data sheet. You should always demand a safety data sheet and a technical data sheet. What I do with my large OEM customers, job shops don't normally require a certification form. But what I do is I sit down with my OEM folks, we look at their spec, and we look at, okay, how thick does this need to be? What temperature do we need to bake this at? What pencil hardness do we want? The crosshatch, what gloss? All those things come into play, even the color readings. We have machines that we can read colors that the naked eye cannot pick up on. But we set those standards, and then we send a certification sheet certifying that this powder meets or exceeds the customer's designated requirements in their specifications.
Just real quick, let's say there is a reject. Can that part be reworked?
Absolutely. You can do many ways of reworking powder. It's going to depend on the powder itself. It's going to depend on the thickness that the powder was applied to, and it's going to depend on where the surface is. If it's a Class A surface, a lot of times it's best to just go ahead and strip the part. If it's just a given spot on a part, you can sand it, you can feather it out, and then you just spray the powder right over it. Powders will intercoat with each other, but sanding and recoating is done every day in just about every shop.
So you've been doing this a lot of years. Let's talk a little bit about technology and innovation. What excites you? What are you seeing moving forward in this industry?
One of the things that excites me is the metallics that even 10 years ago, we played with it, but we never could perfect it. I deal in the casket industry, and I have a casket manufacturer, and we actually are selling him powder coating for his caskets because now we can make them look like the wet caskets with all the metallic in them.
There's a lot of time and effort put into mirror polishing. Are there coatings out there that are able to produce that now?
You know what? We're getting closer and closer and closer to that. I can make a mirror coating, but it has to be clear coated. And the reason is when it sees humidity, it will start to turn black. So what we do with those is we lay down a really beautiful chrome looking powder, and then we come back with a clear for longevity. There's powder coatings now that actually look like chromates and anodizing. But then you have wrinkles, you have multicolors. The other thing that is really getting popular on motorcycles and on car parts, they're called candies. And what you do is you lay down a dye field, red, blue, green, or yellow, and then you put a clear over it, and it looks like a piece of candy. And so they're referred to as candies. Those are always exciting because they're so innovative.
You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.